Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
So the first thing that we were going to talk about is just briefly, because this is going to be a short podcast, just the fact that Python passed Java.
On the Tiobe Index.
Yeah. I mean, of course, there's all kinds of variations on that, but it's still an interesting data point. And for me, the fact that, at least my perception of Python was that it never set out to be a dominant language or anything. It was just satisfying the needs of its community.
Yeah.
And the fact that after all this time, it's gotten more and more successful it's just interesting. It didn't have any marketing behind it.
Well, if you think about Python 10 years ago, it was just like a thing and people liked it. Mm-hmm. But like you said, there was no like thing from the community of Python that's like, we got to get everyone to use this. Like it didn't, people were like, if you want to use it and you like it, great.
It was exactly the opposite, because when people complained about it, they go, I don't want to use Python because I don't like indentation or whatever. And the Python community's response is, cool.
Yeah.
We're not trying to push anything on you.
Yeah.
And so I feel like it's really interesting.
Yeah, and you told me something earlier about in the Tiobe blog post about some of the speculation on kind of what has helped drive it to.
Yeah, the guy who I guess runs the Tiobe site or whatever he posted, and his analysis was just that we need more programmers to do, to solve problems, and they don't all have to be super sophisticated, deep, doesn't require Rust to solve every problem. And so there's a whole lot of problems that can be solved with Python, and people can come up the learning curve, and it's a really friendly community and very supportive and very inclusive. And so I think that has a huge impact on it.
Yeah, I've done a little bit of Python, and my impression of it was always that I have no idea about this language. Like I don't know anything about Python, and yet I can be productive. And that was always pretty astonishing to me, because it's never been to that extent with any other language. There was always like some point where you had to like really kind of understand what was going on. Whereas with Python, you just write code and it works.
Yeah, that was my very first experience with it. After discovering Perl and just interactive languages in general, because I had mostly done things like C and C++, and before that assembly, all things where you had to get it all right first before it would run. And so when I played with Perl, it was like, oh, I can just, poke at this thing and play with it, and it does stuff. And then a couple of weeks later, I couldn't read my own Perl code. And then I started looking at Python, and I think the first problem that I was solving was resizing some images or something. Okay. And I thought, well, I wonder if there's a library that does this. And so sure enough, there's a library. Well, this function here looks like what would resize the image. It probably won't work, but, and then it worked. And with going from not knowing anything about solving that problem to having the problem solved and all the bells and whistles was like a half an hour.
Yeah.
So it was,
just amazing productivity.
Yes, amazing productivity. Yeah. And it has its, there's it.
Yeah. So remember in our episode we talked about developer experience and what makes a good developer experience, and I just did a talk on this yesterday, so it's fresh in my mind. Mm-hmm. But in my guy Ray and I's it's called the Principles of Developer Experience. The foundation of it is that good developer experience is all about productivity. Mm-hmm. And productivity can be measured as how much value does this thing give me over versus how much time does it take me to do this thing. And if you look
you have a measure for value?
So it's the way that we have talked about doing it, which we haven't done a whole lot of like real experimentation to validate our claims of what good developer experience is. But the way that we claim we can do that is to just ask the user, like were you able to accomplish what you're trying to accomplish? Mm-hmm. And that's the way to measure value in the terms of developer experience. Is like in your case, you were just trying to resize images, and so that was your goal. And when you used Python, you were able to accomplish that goal. And
way
then
faster than I would have.
And so then that's the time
C++,
angle.
yeah.
And so I think that one of the great reasons why Python has done so well is that really in terms of that definition of developer experience, it has an amazing developer experience for a lot of use cases.
I like that idea of just asking the developers, how was your experience? Because it could be there's all kinds of things that could vary and that they can't necessarily put a number on, but they can tell you, this was good.
Yeah.
This was helpful to me.
Yeah. Well, so a lot of like documentation and sites that ask you about your developer experience, it's like, just rate this experience, and when you look at it that way, it doesn't
mean try and put a number on it?
Just through that framing of the question, it doesn't actually give you any information as to why it was a bad experience. And so what Ray and I were trying to do was let's create ways to measure developer experience that can actually help you understand how you can make it better. And so that was the whole point of the principles of developer experience. But anyways, I think through that lens, like Python is amazing. Like I don't love Python because it doesn't like fit my ideal of a typed functional language and all that. But the productivity is pretty darn amazing, and in part because of the language, and in part because of the ecosystem. The like in your case, there was a library that did exactly what you needed, or in a lot of cases, there's a code snippet that you find that does exactly what you need, or whatever. And so,
so on that topic, you had another developer experience where you took something and completely converted every aspect of it to Kotlin.
Yes.
So tell us about that.
Yeah. So this was for a session that I did this week called Kotlin Mullets, and the idea of it is what is it? Business in the front, party in the back is the mullet.
Okay.
And so the talk is about how we can use Kotlin on the client side and on the server side, and which is becoming more common. But what I did, so this is something that I worked on, I started working on about a year ago and did some other presentations on, but I updated it and made some modifications to it for the presentation I did this week. And so it's this fun little app. It's got an Android app that you like wave around in the air, and then it sends the data to a server. The server takes the data, turns the accelerometer data from the phone into an image to try to see what you drew, and then sends it to an AI service to try to guess what you drew. So it's this fun little demo. But so every piece of programming in it is Kotlin. So the Gradle build, Kotlin. The Android is all Kotlin. So before in Android, most of Android's history, you would program the UI, the view part of the UI in XML. And they've been working to replace that with Kotlin in something called Compose. So now my whole Android UI is all Kotlin. The like, in the MVC-ish, I don't know what they call it, the architecture for the view, but so the thing that's actually processing the interactions, that's Kotlin, and then the actual definition of the UI is in Kotlin, and they've got a nice DSL for creating the views and all that. And it was my first time working with Compose, and I had some challenges. It wasn't. It's not quite the happy path yet. I can kind of see how it's gonna get a lot better, but it's still pretty early.
So the problem was that it was just that they're still working on it.
Yeah. So a concrete example was when I send the accelerometer data off to the server, that should really be a suspend fun, because it's asynchronous to make a I/O call. And it turned out it took me a while to figure out how to have a button click handler that would call a suspend fun. And I think I got it working right, but there were unfortunately very few examples. Well, actually there are kind of no examples out there of how to do that I could find. So that was a little bit of a challenge, but I think I got it working correctly. So the Android UI is all Kotlin. The Gradle build is all Kotlin. There's a common library that is shared across the Android, the server, and the web piece. That's obviously Kotlin data classes, and that one uses Kotlin multi-platform so that it can target different so JVM and JavaScript essentially. So then there's a server piece that I wrote in Micronaut with Kotlin, and that's all suspend fun, nice stuff there. And then the actual UI for the web that shows you what you drew, that's has to be JavaScript because it runs on the web, but I use Kotlin JS, so I wrote that UI in Kotlin, it generates the JavaScript. And then the actual HTML page is also Kotlin because there's the Kotlin X HTML library for writing HTML in Kotlin. And I think that was all the Kotlin, but it was just like every piece of programming was Kotlin, and that was fun. There were some challenges with like fitting all the pieces together and Gradle builds, and there's challenges with like getting IntelliJ to work correctly with that project and all that. But it's called AirDraw Demo is the name of the repo. It's on the Google Cloud Platform GitHub, so if anyone wants to check it out. But I want to add some other pieces to it as well, because right now it's Android web and server, but I should be able to also do iOS using Kotlin native. And then just this week, JetBrains announced Kotlin Desktop. So it's Kotlin native for building desktop applications, which looks really interesting too. So I need to explore adding those pieces into this project.
So would I have to move my monitor around? Is that how I would draw things?
I'm not sure what I'm going to do with the desktop part.
Maybe just use the mouse, I suppose.
Oh yeah, we could just This is not quite as much fun. It would be cool if your mouse had an accelerometer and you could wave it around. But so I do want to do a Raspberry Pi or Arduino, something like that with Kotlin native. And I have the accelerometers that I can use in a Raspberry Pi or whatever to do that. So that'll be another one, is do a little IoT client. Then I could take a Raspberry Pi and wave it around in the air.
There you go. What was the experience? I mean, was it noticeable that you didn't have to switch languages? I mean, did that change your productivity or your developer experience?
I do think that there's some benefit to the code sharing that you can do across the different ones. In my case, my data model was really simple, so it really wouldn't have been hard to recreate the data model across different clients. But it was nice that I didn't have to. And I'm sure that for a larger project where you had a more complicated data model, that shows its value more. For me, I'm pretty used to polyglot programming, so it's not that hard for me to hop between 5 different languages, except for whenever I go to JavaScript, I always write println instead of console.log. That's the hardest thing about switching languages.
But that's interesting, because I know that, I mean, I always heard that like one of the big arguments for Node was because I know JavaScript, and so I want to be able to program JavaScript everywhere. Yeah. And so I'm always kind of curious as to how big of an impact that is, because it seems like you also pay a price for that. Yep.
Yeah, it's there's certainly challenges, I think, with that universal language concept, because you're working with an abstraction over some other thing. And so there's always places where things get a little bit weird. Like, so in my case, I spent a few hours debugging a problem where when I tried to run my JavaScript client, I was trying to call is not empty on a list. So my list is defined in Kotlin. I was trying to call is not empty on it from the JavaScript side, like in my Kotlin JS code. And when I ran, it compiled fine and converted to JavaScript fine. But when I ran it, it would say like is not empty, doesn't exist on this thing. And so I'm like, okay, this has just got to be a bug somewhere. And I know that they're like reworking the whole Kotlin JS backend and all that kind of stuff, but it's just, I'm sure it's just a bug. Anyways, I was like, at some point I exhausted all ideas on how to deal with this. And I was like, let me just change list to array or something. And all of a sudden it magically worked. I'm like, okay, clearly like just a bug, but that's just an example of like, like there are challenges and there are bugs when we're working with these things that generate code for other platforms. And it's never as easy as it sounds. So is it worth it? Like in the real world, this is just a demo. Like in the real world, do I think this is like a viable approach? Like, I don't know. Like,
maybe not yet.
Maybe not yet. Yeah.
Yeah.
It still seems kind of early, but
because I'm also on board with you about polyglot programming. Just use the language that does the best job for the project, and use multiple languages if that solves your problem.
Yeah. I think where things could get more interesting around this idea of like a universal language is around also a unified UI programming model. So I think that's where a lot of the cognitive overhead comes in, is that it's not like the language isn't that hard. It's all the things around the language on top of the language. If I were to do the same thing in like TypeScript, I would probably use React or like some more web friendly UI framework. And so then I'm like switching between like Compose and Android and React for the browser. And if I did like a desktop or some other iOS version, I'd be switching my UI programming model. And UI is just one kind of place where this exposes itself. Asynchronous stuff is another. It's nice to use coroutines everywhere, for example. But this is not reality yet, at least with Kotlin, to have a universal UI programming model. Compose does work with Kotlin, the newly announced Kotlin desktop stuff, which is nice. But I think I've seen stuff around using Compose for web applications. And if they got that piece, then it's like, okay, then, like I think it's going to take years to like work out all the bugs and kinks and all that kind of stuff. But I think that's when it becomes much more interesting, is not just like sharing your data classes and a little bit of logic around, but being able to really have a consistent programming experience end to end for all the different languages. And I don't know what the deal is with like Compose for Kotlin native on iOS. So still more exploration there, but I want to believe that this could be a happy path in the future, but I'm not convinced that it is yet.
Well, and I mean, Google has that, UI everywhere.
Oh, Flutter,
right. Yeah. And I know that they're putting Flutter for the desktop as well.
Yeah, I did see that.
So that's also promising.
Yeah, if I could use Kotlin and Flutter, like that would be interesting. Mm-hmm. But it is interesting that Google has Flutter and Compose, and Angular. Like a lot of different UI frameworks
a lot of experiments.
That's right.
Yeah.
Yeah.
You were also talking about making illegitimate
this is a topic that's come up. We've kind of touched on a few times, but we never have gone into much detail about it. So it comes from that world of Haskell, which I don't know anything about the world of Haskell, but that's I believe where the statement comes from, and it's that this idea that you want to make illegal states unrepresentable. And an example of this is if in my program I have a list that can never be empty, like it always has to have more than 0 items in it. If you just use a standard list, that's not your type system. And really this is just about type systems, because I think if you don't have a type system, you can't really do this. So so it's really about when you have a type system, making your type systems represent what the legal states are. So if something cannot be an empty list and you just use list, then your type system is actually not conveying that characteristic that you're requiring. And so there's this push from Haskell folks, and I'm totally on board too, even though I'm not a Haskell person, to make your type system as accurately reflect the constraints that you want to convey.
So, but you're talking about static checking, right?
Yeah. Yeah. I don't know if you could do it any other way.
Well, I mean,
maybe.
Sure. I mean, you could just say, here's my list, if it ever has. I mean, it's like preconditions and postconditions. You just check.
Yeah. Well, so I guess that's a good point to clarify is that I think that the statement really means that it shouldn't pass a compiler or validation step. And so maybe you could use a linter or something like that. I don't know. But in your case, where you're saying you could do preconditions, what that is an exception or some sort of error handler that you only see at runtime. And that's exactly what the idea is trying to say is things that you can validate in the type system, validate in the type system so that it won't compile with invalid states. And so that's how it's different from, I think, dynamic languages or non-statically typed languages. Is I think you can only do
or
this for
statically typed languages that don't have that kind of support, where you have to put in preconditions and postconditions.
So there's some aspects to this that get a little more in the weeds, and I'm not an expert on kind of the type theory parts of it, but there are like 4 ways that a type system can provide constraints, and the 4th one, which Scala, which I use a lot, doesn't have, is called value dependent types. And these, in your type system, you can actually encode the constraints kind of like a type proof. And
these are the things like how long your array is.
Right, exactly.
Okay.
Yeah, that would be something you could encode into the type
Which
system.
is the only example that I've ever heard of that, by the way.
Yeah.
So that makes me a little suspicious.
Well, so that I could give you a lot of examples.
Okay, all right,
yeah.
good then. You don't have to now.
Okay.
But as long as they're there.
Yeah. Yeah. So the builder pattern, I've been on this like rage path against builders, as everyone who listens to this knows. But that's been one of my big kind of knocks against the builder pattern, is that the builder intentionally doesn't convey the constraints in the builder. It does when you call .build, but that's not making illegal states unrepresentable. And so I'm working on this example where I'm taking all the ways that we use builders and showing people how you can instead encode the constraints for those things in the type system and make illegal states unrepresentable instead of trying to do it with a builder. And so where this comes down to ADTs, algebraic data types, which we've talked about before, is that there's a lot of times when ADTs become a good way to represent something that can be one thing or another thing, as an example. So yeah, in my rage path against builders, I keep pointing out to people, like, your builder doesn't do this, and that's one of the problems with it.
So my concern with these more and more elaborate type systems is the complexity that it could impose upon the programmer. And I feel like we came across this when we were interviewing Cedric, and he was making the argument for the null return value to be able to chain operations together versus full-on monads.
Yeah.
And I think his argument was basically, well, you have a complexity trade-off. And so that's what concerns me about this language that you're describing is like, how complex is it going to get to be able to achieve those things?
Yeah.
And are you going to have is it going to pay off?
Yeah. 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 I agree. There is a complexity cost to it, to trying to make your program be not able to represent illegal states, and I guess like I'm totally bought into the idea. So I value this enough that it's worth it for me to make this trade-off in most cases. But you
don't really know what the trade-off is yet, though, do you?
Yeah. Because,
it could become just massively complex to represent these things. So,
yeah.
It
already is. And it can be a lot harder to deal with monads or ADTs than just deal with something that can be null. And so I think this relates to our conversation about how, like, there's the happy path that we want to be on. but there's a gap between like the real happy path and the like making the programming model easy and approachable, and so I think the question is like, can we converge those two things? Like, just as an example, having actual like nullability, having a method that returns a value or returns null really is a simple programming model until you have to think about the possibility that it can be null. But if you don't want to think about the possibility that it can be null, like, it's a lot simpler to just look at a method and be like, oh, this thing returns an int. And like, that's simple. But if you want to think about like, okay, this method can return an int, or it might be null, then all of a sudden you need some added complexity to help you address that. And Kotlin did a great job of addressing that complexity, or you could use ADTs, or you could use monads. But yeah, definitely there is a complexity cost to it. And I wonder, like with nullability, Kotlin's decided that the added complexity was worth it.
Well, and I think they were looking at it in comparison to monads. They were going, monads are too much, and this is, we can add a few operators in the language and force you to deal with anything that's nullable, and so that's a reasonable compromise.
Yeah.
But it also feels like a transition path.
Yeah.
And at some point, it would be nice to have something, I don't know, more monadic, where we could, but then you've got that complexity factor.
Yeah.
And, I can't compose two functions until I understand, flat map.
Yeah.
And why.
Yeah. And
all that, so it's like, it's giving us these benefits. I mean, going back to Python, it has, it allows you to go in and just kind of flail around and get something done. And you're leaving a lot of possible failures on the table. And yet you're able to get this thing done without massive amounts of complexity. So there's your trade-off.
Yeah.
And well, in my experience with Elm, because I really wanted to get Elm, and there were parts of it that I just couldn't wrap my head around.
Yeah.
And
whereas jQuery was just like so easy. It's like,
you do this.
You do this. Yeah.
Right.
Yeah.
Right. And it's like, man, it's so tough, because what is the happy path?
Yeah.
And the happy path may be, okay, I can easily define an ADT here, and then it's taken care of, and it's got my back if I start messing up.
Yeah.
And then if it's easy enough.
Yeah.
But then if I have to understand these really sophisticated concepts in order to write Hello World.
Yeah.
I don't know.
Yeah. Yeah, I think it is trade-offs. But what I really wonder, like, you look at Kotlin's nullability question mark stuff, it really made dealing with nullability easy enough that I think people are willing to have that front and center in the programming model. Mm-hmm. And Kotlin did that with nullability. I don't know if they were the first ones or not that did that, but
I think, well, most of they like intentionally stole features from other languages, so it might have come
C#
from
or TypeScript
C#
or something.
I think it might have been C#.
Yeah.
Yeah.
So I wonder, what else is going to have that same path? Like in 5 years, are we going to be like, oh, ADTs have been made so easy by this language that now they're just generally the way that we do things.
Because they're going in Python. In the next version of Python, it looks like there's going to be ADTs.
Yeah, so. And I think Java is getting something like ADTs as well. Not quite in the same way as others, but yeah, Python is getting ADTs. So, and then, maybe 10 years out, like, we'll be talking about monads in this way. Be like, oh yeah, monads are so easy now.
Mm-hmm.
So I think there is this natural evolution towards making the happy path easier to do correctly. And so, but right now, like, I live in the reality of trying as hard as I can to make illegal states unrepresentable, and it's the way that I want to program. But I've totally bought into dealing with some of the pain and struggle that comes along with that.
Because you have had enough experience that you see the benefits of not having to think about that aspect of things. You just go, oh, the state machine can never go into that state.
Yeah. And I've invested, many years into Scala, which makes it a little bit easier to do this with the type system. So I think I've learned the tools well enough that, whereas I think for most programmers, if I tried to say, okay, now use Scala to make your illegal states unrepresentable,
you have to explain the concept of making the illegal states unrepresentable, and then convince them that it's worth all the effort, and then teach them the mechanisms to do that. And that's, I think you're gonna, at least for the time being, that's a big hurdle.
Yeah. There's another one that's another interesting aspect to this that is, I think, called phantom types or type aliases in Haskell. And I may be getting this wrong, but the idea, as far as I understand it, is a lot of times in your code, you'll say, all right, this method takes a string. And so you can pass it any old string you want. But what you can also do is create a type alias for something, a type that essentially extends string. And so now, let's say that you have a method that takes an account ID. The actual type of the thing that you're taking is not a string, it's an account ID. It's something of type account ID. But you work with it just like a string, but this prevents you from accidentally passing a
string.
A string that is not an account ID to this thing, is that you get some validation in the type system. And so it becomes much more evident, like, oh, I tried to pass a person ID instead of an account ID
and the
to this
compiler
thing.
will tell you that.
Exactly. The compiler says no,
that's not what you said you were going to use here. So it's a little tighter.
So it's this lightweight way to, and a string is just one example. Like, you could do it with any type essentially, but coming up with more specific names for things that the compiler can then validate on. It's not foolproof, because you could certainly accidentally, when you create the person ID, make it an account ID, and then the compiler says you're all good. Like it's not, it can't. There are things that can't protect you against.
But there's a trail. I mean, you can go see where you do that.
Yeah.
So, yeah.
So that's something I've been using more in my programs, is these. There's a couple different ways to do it in Scala, which is unfortunate that it's not quite built into the language like I think it is with Haskell. But
so
I don't know if there is a way to do this in Kotlin or not, but
I mean, there is I'm pretty sure there is an alias thing. I don't know that we talked about it much, but it's like a type def in C++. And it's not that new of a concept, but I don't think it gets a lot of use.
So this is a little bit different than in Scala. You can say type foo, equals string or something like that. And so then you get a new type foo that is just a string. But when you do it that way, and let's say you have a method that takes a foo, you can still pass a string to it. So it doesn't actually require you to pass the type that you have just created an alias for. You can still pass the underlying type. So it's not actually giving you the compiler guards that you really want. I think there are some languages that have these like type aliases, but it's not exactly what I'm talking about with these phantom types or type aliases or new types or something.
So is this idea of making illegal states unrepresentable, is that something that could be, say, a chapter in a book on Scala? Is that
what's interesting is it's a verbiage that gets tossed around a lot, but I've never seen much content where people actually talk about what it really looks like and what it means.
How you design that way.
Yeah.
So it seems like ripe for coverage.
Yeah. I think John DeGoes has done a good job. He comes, or at least has a lot of experience in the Haskell world and brings that to Scala. So I've seen content from him that talks a lot about this. And so that's been helpful for me. But I don't know if I've seen many people that are like, okay, you're a Java programmer, you're writing builders, here's why that's wrong. And it kind of goes into some more concrete examples of how Java developers in particular could embrace this, and why it would be good for them to do so.
Maybe that's how you're going to make your mark on the world.
That's right.
It's the anti-builder crusade.
Yeah. I think that's the second crusade I've launched on this podcast.
Yeah.
But the first one was on custom DSLs.
Oh,
yeah.
Right. Yeah.
Yeah, custom declarative languages.
Yeah.
Okay. Gosh, I have too many crusades up in the air right now. I need to focus.
Mm-hmm. Yeah. Well,
or I could just pick the next one and move on to it.
That's true. You could just start crusades and then get them going and then move on.
And move on to the next one.
Yes. Well, with that, I think that's today's podcast.
Yep. All right. Thanks for listening.